Okay, this video explains how to calculate percent composition and how to use it to do different types of calculations in chemistry. The first thing that you need to know is that any percent is a part over a whole of something. It's basically just a proportion or a ratio. For us, we're going to use the mass, and it can be called percent by mass or percent mass. So if we are asked to find the percent hydrogen in H2O2, you need to find the part of something. The part of something is the H, is what it's asking about, the percentage of hydrogen. We're going to use the mass of hydrogen. And we're going to do this like we've done the molar mass problems in class. The molar mass of hydrogen is going to be 2.0 grams because I have two hydrogens and each one has a mass of 1.0. So if I have a compound of this, 2 grams of it will be made up from hydrogen. Then I need to find the all of something. All of something is the mass of the whole thing. So the mass of 2 oxygens is 32.0. The mass of 2 hydrogens is 2, so that adds up to be 34.0 grams of H2O2. So in 1 molecule of H2O2, 2 grams of it will be hydrogen. If I multiply that by 100, I will end up with 5.9% hydrogen. Then I can find the percent oxygen in H2O2. It works the same way. The part is oxygen, the whole is hydrogen peroxide. I have to go by my formula, so don't forget that there's 2 oxygens. That makes 16 become 32.0 for the oxygen. And then that gives me still 34.0 grams of H2O2 from before. And if I multiply that by 100, I will end up with 94.1% oxygen for every amount of H2O2 that I would have. It doesn't matter if I have 100 grams or 10 or 52, 36.9, however much I have of it, 5.9% will be hydrogen and 94.1% will be oxygen. Now, there's a couple different kinds of problems that you can have that use percent composition. The first one is one that basically in some way asks you to find the percent composition of a substance. If I'm asked to do this, it may specify determine the percent sodium in sodium chloride, or it may just simply ask me to do everything. Then I need to find the percent of sodium, and I need to find the percent of chlorine in this particular problem. It's the same way, part over whole. The part is the sodium. So sodium has a mass of 23.0 grams according to the periodic table. And this together will have a mass of 58.5 grams if I add it up for the Na and for the Cl. If I multiply that by my 100 to make it a percentage, then I will end up finding that I have 39.3% sodium no matter what I have of NaCl. For the chlorine, chlorine has a mass of 35.5 grams. My compound doesn't change, it's the same as before, it's 58.5 grams. Multiply that by 100 and I will get 60.7% chlorine. A second type of problem that you can have can be formatted kind of like I have. A compound is made of 22.1 grams of sodium and 34.1 grams of chlorine. Find the percent composition. They still want me to do the math. It's the same premise as before. The difference is they made it a little easier because they gave me some of the numbers. So if I'm still being asked to find the percent sodium and the percent chlorine, this time I have the parts right here. This is the part that's sodium right here. This is the part that's chlorine. So on this side, I know it's going to be 22.1 grams of sodium, and I know it's going to be 34.1 grams of chlorine. What I don't know is what the whole is. The whole is going to be NaCl. I add the two things together. So that's going to give me 56.2 grams for my total. And if I work this out, I'm going to find out the percentages, which should be the same as what I did before, that it's multiply it by 100, you'll get 39.3% sodium, and you will multiply this by 100 to get 60.7% chlorine. The reason it works out the same, even though my numbers are different, is because it's always the same ratio. It's always going to be the same percentage no matter what I have. A third way that I can use this is down here at the bottom, a question that reads kind of like follows. If you have 82.3 grams of sodium chloride, how much is sodium? It could ask you to find either element, and it could ask you to find more than one thing. But in order to do this, I need the percentages. It works along the lines of what I'm saying, that I don't care how much I have of sodium chloride, 39.3% of it will always be sodium. So if I have 82.3 grams of it, in order to figure out how much is sodium, I need to know the percent composition of sodium chloride. Well, I already happen to know that the percent sodium in sodium chloride from up above is 39.3%. So however much I have, in this case it's 82.3 grams, it'll be that times 39.3%. Biggest thing I find here that students make the mistake of is forgetting that when you multiply and find a percentage of something, that I actually need to turn this back into a decimal number. I need to divide it by 100 first. So in order to do the math, 82.3 will actually end up being multiplied by 0.393. And if I do that, I get 32.3 grams of sodium out of the 82.3 total. Alright, stay tuned for more videos on molecular and empirical formulas.